Thank you for watching this video. I'm Masayuki Ono of the Tokyo Electric Power Company. I deeply apologize to the people in the areas surrounding the Fukushima Daiichi nuclear power station and to the broader society for the tremendous inconvenience and anxiety caused by the accident at the power station. I would like to detail progress in the removal of highly radioactive contaminated trench water, an important step being implemented with urgency as one measure in the removal of contaminated water. I hope this video will help you understand this measure. This is a photo of units 1 to 4 taken from the air. As explained in the previous series, groundwater near the protective bank east of the turbine buildings was found contaminated with radioactive material. Therefore, we are currently implementing a measure that will prevent groundwater leakage into the port. This measure is to seal the soil near the protective bank by injecting liquid glass, which makes soil solid and impermeable. This is a map of the underground tunnels called trenches on the seaside of the turbine buildings. The trenches extend from the turbine buildings to locations near the protective banks. Highly radioactive contaminated water that had accumulated in the basements of the turbine buildings following the accident has also accumulated in these trenches. Leakage of highly radioactive contaminated water from inside these trenches is considered the cause of the contamination of groundwater near the protective bank. Immediately after the accident, there was an incident where contaminated water that leaked from the trenches of Units 2 and 3 leaked into the port. We then stopped the leakage by blocking the parts of the trenches near the leakage spots, filling the areas with concrete. However, highly radioactive water that had previously leaked into the ground may still be causing contamination. Further, since there has been extremely contaminated water accumulating in the trenches of Units 2 and 3, even leakage of a slight amount of this water into the port would increase radioactive material densities in seawater near the protective bank. This is a three-dimensional illustration of the trenches of Unit 2 from the sea. Between the turbine building and the protective bank, we have an underground structure as shown here. Large amounts of highly radioactive contaminated water have accumulated inside the trench's main bodies. For example, approximately 5,000 tons in Unit 2 and approximately 6,000 tons in Unit 3. Since the accident, we have taken measures to prevent this contaminated water from leaking into the ocean. Further, we recognize that removing the contaminated water is an urgent, key task. However, construction work to remove contaminated water from inside the trench's main bodies is difficult because the radioactivity around them is high. For this reason, the construction method was carefully considered. I will explain a measure we took at the first stage. This is a schematic side view of the trench where highly radioactive contaminated water has accumulated. The orange area shows where it has accumulated. First, we installed a mobile contaminated water purification system. Highly radioactive contaminated water is sucked up from the seaside part of the trench, purified, and returned to the trench near the turbine building. The contaminated water is purified while being circulated through the inside of the trench in this manner. Why is the water sucked up from the trench and purified returned and circulated through the trench? The reason is that, since the trench is connected to the turbine building, newly contaminated water will flow into the trench from the turbine building unless the purified water is returned to the trench. It's clear that stopping water between the turbine building and the trench is an absolute requirement for finally removing contaminated water from the trench. Practically speaking, however, this is very difficult. I will explain more about this difficulty later. This mobile contaminated water purification system mainly removes cesium. Removal of cesium, which accounts for approximately half of the contaminating material and which emits strong gamma radiation, can reduce risks such as the risk of radiation exposure from the accumulated water during the work. The treatment capability of the system is 500 tons a day. The purification treatment operation was started on November 14, 2013 for Unit 2 and on November 15th for Unit 3. As a result, the cesium-137 density near Unit 2, for example, previously at levels as high as 170 million becquerels per liter, was reduced to approximately one-third of that level after purification operations of about a week, and the purification operations are ongoing. Next, I will explain the second measure in detail. This step is an absolute requirement for final removal of contaminated water from the trench, namely, stopping water between the turbine building and the trench. The trenches of Unit 2 and 3 are connected to the turbine buildings underground. For this reason, newly contaminated water flows into the trenches no matter how much contaminated water is removed from these trenches. Stopping water between the turbine building and the trench is absolutely necessary for removing contaminated water from the trenches and stopping up the trenches with filler. However, as the trenches are filled with highly radioactive water, working there is dangerous. As such, development of a water stoppage method has been a substantial technical challenge. In response to this challenge, we have developed a water stoppage method in which the contaminated water inside the trenches is frozen. Since this is an application of new technology, a mock-up test was conducted to examine whether the water can actually be stopped. Now let me explain about the frozen water stoppage method. First, a hole is bored in the upper side of a trench with a drill, and a freezer pipe is inserted into the trench. Next, a fabric bag called a packer is inserted so that it can surround the freezer pipe. Then, this packer is expanded by being filled with cement and a material called bentonite, thereby blocking up the trench. This facilitates generation of an ice wall. By being refrigerated in this state, the water inside the trench is frozen together with the packer, so that a strong ice wall is generated for completely stopping water. Finally, the accumulated water in the trench is removed. Again, this is a new method created in response to this challenge. The frozen water stoppage method was originally intended to generate frozen soil by inserting a freezer pipe into the ground and freezing the water contained in the soil, a proven technology for this purpose. However, freezing accumulated water itself to form an ice wall in a desired location is being tried this time. In practice, it is very difficult and has never been tried before. Now let me explain about the results of the mock-up tests. This is a mock-up unit. This is a large-scale unit, fully half the size of the actual one. This is a mock trench measuring 2 meters in width and 2 meters in depth. A freezer pipe is installed separating the front and back sides of the trench. This is one of the test results, and you can see an ice wall already formed. Water accumulated in the front side has been removed. The part behind the ice wall has water 2 meters deep. Water inside the trench has been completely stopped by the ice wall. This is another test result obtained in a test case simulating a case where obstacles, such as piping and cable trays, prohibit full insertion of the packer. In this case also, an ice wall was successfully formed with an increased number of freezer pipes. As in the above case, the part behind the ice wall has water 2 meters deep. For example, as you can see, the piping has been blocked with the water inside it frozen. Based on these tests using our large-scale mock-up unit, we can now clearly see that we will be able to solve the difficult problem of stopping the highly radioactive contaminated water accumulated inside the underground trenches. Please note that the ice wall will not leak water because it is capable of repairing itself. Even if it develops cracks, water penetrating into the cracks will be frozen. Additionally, the ice, formed in a frozen wall over a long time, is not easy to melt. We will start with the freezing of the Unit 2 trenches beginning around March 2014. Complete formation of an ice wall will take a long time. However, we are planning to form a strong ice wall and then start removing water from the trenches in May 2014. After the water removal, the trenches will be blocked with filler. We will proceed with implementation for Unit 3 following the results of implementation for Unit 2. We are determined to steadily solve on-site problems using this technology. Thank you for watching this video.